Hello everyone, let's solve one more question based on uniform acceleration motion in vertical direction. Question says a stone is dropped from the edge of a well and the sound of the splash is heard after 3.4 seconds. If the speed of sound is 340 meter per second, how deep is the well up to upper level of water? From the given description, we have tried to draw a sketch. Now this sketch represents the given situation. There is a well, there is certain water at the bottom of the given well, and we are dropping a stone from the edge of the well. When we say we are dropping a stone, of course at the point of release the velocity of that stone has to be zero. And now because we are releasing it, we are just making it fall freely into the water inside the well. While moving in the downward direction, it's following uniform acceleration motion under the action of gravity, so its velocity is going to get increased, as we can judge. So it is nothing but uniform acceleration motion for the stone. It is mentioned that the stone falls in the water inside the well, and then the splash of the water is heard after 3.4 seconds. Remember, stone is dropped, it reaches the water level, the upper water level, then the sound is generated, and that sound travels vertically upward, and here at the edge of the well that sound is heard. And that total time is given 3.4 seconds. Let's consider that the distance the stone has to travel to hit the water level is h. So this height, or let's say depth of the well up to the water level, we have to calculate. How deep is the well up to the upper level of water? That we have to calculate. So let's assume that the depth of the well up to the water level is h. So we have already discussed that the stone is following uniform acceleration motion, having initial velocity 0, and it is having a constant acceleration of gravity. Velocity of the sound is constant, 340 meter per second. We know that the sound travels with the same velocity throughout. So the motion of sound is going to be uniform velocity motion. So here there are two different types of motions involved in the same question. Stone following uniform acceleration motion, whereas the sound following uniform velocity motion. Let's try to find out this unknown height h, or the depth of the well up to where the stone has to travel to hit the water and to generate the splash. And then the sound will come out and it will be heard, and that total time is 3.4 seconds. Let's see how we can solve this. So let's assume that the time taken by the stone to travel this depth h is, let's say, t seconds. So the stone reaches water level in time t. For the uniform acceleration motion of the stone, using the equation s equals to ut plus half at square, the displacement of the stone is by the depth h. So h is equals to ut plus half gt square. Because the stone is moving in the vertically downward direction, remember here we are going to take g, acceleration of gravity, positive. That is our decided sign convention. So we are getting here equation after substitution of the values. H is equals to 4.905 t square. Let's say this is equation number 1. Now once the stone hits the water, sound is generated and it moves with constant velocity 340 meter per second in the upward direction up to the edge of the well, and there it is heard. So the motion of sound is nothing but uniform velocity motion. Now if we have considered that the stone is going to take time t to reach the water level, then the time taken by the sound to start moving from the water level and reach over here at the edge of the well is going to be 3.5 minus t. Are you getting it? We have said that the stone is dropped and the sound of the water splash is heard at 3.4 seconds once the stone is released. So from the release of the stone till you hear the sound, that total time is 3.4 seconds. So if only we are considering time taken by the stone to reach the water level is t, the remaining time will be taken by the stone to reach, the remaining time will be taken by the sound to reach the upper edge of the well, and that has to be 3.4 minus t. So it should be very clear. So let's use uniform velocity motion of the sound, and we know for that we use the simple formula that distance traveled is going to be always equals to velocity into time. So sound also going to travel the same depth of the well till it comes out at the edge of the well, that is distance h, the depth h, that is equals to velocity of the sound 340 and into the time, which is 3.4 minus t seconds. Let's now that is, let's say this is equation number 2. Now comparing equation 1 and 2, the left hand side of both these equations is the same, displacement h. So obviously the right hand side part of both the equations also must be the same. Let's compare these two things, or you may say that this value of h, whatever we have got from equation number 2, we are going to substitute it over here in equation number 1. Either way it can be done. So comparing equation 1 and 2, let's equate the right hand side parts of both the equations and solving it further, which is going to be a quadratic equation. I hope you can solve quadratic equations on calculator. By this time you must be knowing the procedure. So for this quadratic equation, we are going to have two possible values of time t. One comes out t is equals to 3.247 and the other value comes out to be minus 72.56 seconds. Of course, we are not going to have time in negative value, so that has to be neglected. So the time taken by the stone to reach the water level is 3.247. Now if at all we have to find out how much is the time taken by the sound to travel from water level up to the edge of the well, that will be of course 3.4 minus 3.247. So that much time will be taken by sound to travel from water level to the upper edge of the well. Apart from that, we have to calculate the the depth of the well up to the water level. So we know h is the assumed value of the depth of the well, and we have to calculate that either this value of time t, whatever we have calculated right now, 3.247 seconds, it can be either substituted in equation number 1 or even in equation number 2. We are going to have this unknown depth of the well up to which the water is present. So let's substitute it in let's say equation number 1, and after solving it we get the value h is equals to 51.71 meters. So depth of the well up to the water level is calculated as 51.71 meters, and that is our final answer. Thank you.